Pipelines, right? So for those people that are coming from the Pentaho or Kettle worlds, they were called transformations, and we actually specifically rename them to be pipelines to be more in sync with Beam terminology, and we actually renamed jobs to be called workflows to be more in line with Apache Airflow terminology. And so this is sort of like the backdrop for that. Now, big data support, MapReduce, visual MapReduce, all these things have been developed in the past for Kettle, even in open source. And so you kind of learn things, right? Um, so one of the things that we learned from those experiences is that if you have a HDFS folder filled with files, you don't want to read them in line by line and start tearing those lines apart with split fields, steps, or transforms. So in anticipation of Apache Beam's field metadata support, we actually added a definition for files. And you will find this in the metadata. It's called a Beam file definition metadata type. And what it says basically, so if we read from a folder, whether it's HDFS or S3 or Google Storage or a regular file, you can specify a file separator and specify the file layout, the fields in there, the types, format masks. If you have any CSV file or text file input dialog, you can just copy paste in here, so it's quite convenient. In the standard sample, the samples folder that you see, samples projects that you see, you will find a Beam folder, and you will find a few pipelines in here: input, process, output, generic set, synthetic data, complex. And these kind of like show the possibilities of generating all sorts of stuff, right? So that's something you can look at. So these samples are that I'm showing right now. These are already included in Hop, and you can run them directly. So all you need to do is take customers' input output and run them. Um, so in this case, we're reading a folder with customer data, and we're going to filter out the California people from California, limit some fields, reorder some, and then write it back out to an output folder. This is something that might be conceived as like a hello world exercise. And the other example, complex, this one contains all the special cases. So we're not just reading and writing, but we're also doing things like using regular hop transforms that are not Beam specific, merge join, uh, stream lookup, a aggregation, a group by, a filter rows, directing rows to different targets, and even a switch case, right? Um, for those people familiar with Beam, things like stream lookup, they are site loading basically. There's the data from count per state is being side loaded into the transform lookup count per state, and these are like targeted. So these are all P collections basically, targeting specific transforms based on the condition in this transform. And so there is very little that is not one-to-one translatable between a regular hop pipeline using the regular local or remote native engine of Hop and Apache Beam. And because of those similarities, we decided to just ship with Apache Beam integration for Spark, Flink, and Dataflow out of the box, and the direct runner for testing. Um, so how does this work in Hop? Um, So let's take a look at where are my input files. So these are the input files, just generated data, some state data, and this is where we will expect the output to be. Um, let's take a look. Let's run this. The direct engine is very useful for processing things simply locally, right? Just to see if things are working. And you can specify a number of workers, a temp file, and that's pretty much it. It runs in memory. I don't think it takes too long. It sets up the engine, and there you go. As you can see in the logging, it logs that, okay, so I handle a input transform, a generic transform, which is a generic hop transform, and a specific output transform. So it kind of gives you the logging of what it does to build up a Beam pipeline using the Java API of Beam in the background. And then it says, okay, now I'm going to execute this with the direct run configuration, and it's using the direct runner basically. Um, what you can also do, so this is interesting for people who are interested in doing the unit tests here, is use the local engine to run this. Um, so what you will have then is the classical engine, uh, but since those folders are typically mapped to HDFS or something, somewhere on a Spark cluster or in Google Storage, um, we're saying like, okay, so we're not gonna even try to put files locally. We're just gonna use an input data set. So for the unit test itself, and then map fields from the input from the data set to the input and supply a sort order. And then we're gonna also do a golden data test against golden data set to see whether or not that is correct. And so again, the data set, customers input, that is something that you can look at here. And typically, you store like a few hundred rows or something, or the specific the hard cases, right? The problematic null values or the weird characters. That's the stuff that you put in those data sets to see if your transform or your pipeline survives that. Um, so this gives us the opportunity to do test-driven development even. So you have input and output. Somebody gives you a few hundred rows of data from a HDFS folder and says, this is the sort of input that we require. This is how you would do that. So even a simple example like this can pack a lot of punch. And so let's continue. So what are the other engines that we support? So the Flink engine that is configured in your configuration is also set up to run local. This is done. If you mouse over the labels, you'll see like pop-ups with the explanations. So you can say, okay, local is just a local server, for example. So this will run with the Flink engine. And we'll cover fat jars later. So now we want to say, okay, let's test this on Spark, right? So I thought that today I would kind of like set up a Spark cluster for you guys on my local machine. This is asking for trouble, but no. So just like hopapache.org, we can go to sparkapache.org and hit the download link. And what we want for now is Spark 247. So Beam 2.28 is the latest release, and Hop has that on board in 0.70 of Hop, or the latest nightly builds. 2.29 of Apache Beam, which is about to be released, the next release will include support for Spark 3.0. And after that, you can use 3.0 or 3.1 to your liking. But essentially, what you do is you download Spark 247 bin Hadoop, and even though we're not going to run on Hadoop, we're gonna unzip that in opt Spark. And what you have, let me just make this a little bit bigger, is a folder. And what we did um, is set the Spark home. Uh, so Spark home is set to opt Spark. And I also changed my class path, my path to include opt Spark as bin. And in the as bin folder, you'll see all sorts of things like start master, stop and start slave, stuff like that, right? So the first thing that we can try is um, if you're running on a machine with lots of Docker and stuff like this going on. I'm on IP address 1.6 here on my local environment, and so what I did is added the name of my machine Rigel as this IP address. That's something that Spark often likes. So let's just start the master. And so when we start the master, we can browse to it on localhost 8080, and you will see that. Okay, so we have this thing running. It's literally that painless to set up a Spark master, right? Um, Okay, so we don't have any workers, and a worker is an extra node to the cluster, and so we can I will not slave. So start slave. In this case, I don't want to give it all my memory on my machine, just 10 GB. I don't want to have it use all my cores on the machine, just two. And then I'm gonna point to this address here in the top, uh, which is Spark Rigel 7077. All right. So now it's gonna register to the master and add itself to the cluster. And here you go. So here we have an extra node, which says, okay, you have 10 GB that you can use on this machine. And so I have another PC here, an old PC, where I can say start slave. Here we go. There's another 10 gigs and two cores that I can use. Uh, maybe it's already anyway. So you can add more of these nodes. One is plenty for our demo. If the node goes down or something, it will stay in the log for a bit and say it's alive, right? Um, Now, if you look at these input transforms, you can see that, okay, so the input location data input is set as a variable. Why? Because in my demo, one time it might be Google storage, another time it might be locally, another time it might be on HDFS or wherever, right? And so what we did is, okay, so if I run locally, I set the variable. Didn't set any variables, because it's running off of. If I run on the direct runner, I set the variables to project home, which is just the demo, the samples project home, Beam input, and it's like a 1 KB file that we can use to test. And the output is going to the output folder. So this is how that is done. If I'm using, in my case, Spark, all of a sudden, if I run this remotely, Spark, Project Home might be not that relevant anymore. You might want to map it to some shared folder, some I don't know, some NAS folder or something like that, or HDFS or some other way of sharing the data. So in my Spark configuration, I'm saying, okay, so this Spark Rigel again is the same, and I'm gonna need a fat jar, and Spark needs a fat jar, not for running embedded, but if you're going to say, I'm going to execute Java code on a Spark cluster, you need like a jar file that contains all the code. Uh, so we need to take a step back and say, how are we going to get a fat jar? In Kettle, this was done by producing a zip file. Fortunately, we moved on a little bit beyond that, so we can generate a fat jar and just say, okay, so here I have a whole bunch of fat jars full of various version, and I'm gonna maybe call it Beam Demo Hop Fat Jar or whatever, right? Um, and so you will build a fat jar. It will take, I don't know, 20, 30 seconds. And so it will copy the name of the file to the clipboard, and then you can just paste that um, into the run configuration for Spark, Flink, or Dataflow. So let's give that a second. All right. And so that fat jar is pretty cool actually, because you can even run the Hop GUI from in there, or you can run Hop Run, or everything is contained in there. All the libraries for anything you might need in Hop. And what it will use is your the configuration, the way that it is in the Hop GUI, as you can see it. What you can also do is use Hop Conf, because if you're on a server, you might not have the option of running the GUI and using that method. And somewhere in here is an option. Where is the fat jar? Uh, Here we go. Generate fat jar minus FJ, which uh, allows you to generate that same fat jar from the server. So that means that if you go into plugins and say, well, I don't need Salesforce plugins, I don't need this, I don't need that, you can start throwing stuff out to reduce the size of that fat jar. You're saying I don't need any Spark, I can just delete the Spark library, whatever, right? So it will just pick whatever is under that hop tree. Okay, so this is copied to the clipboard, and then you can go to these pipeline run configurations like Dataflow and just paste it in here. I'm just going to leave the one that I had um, just for convenience. Right? um, so now, if I want to run on this Spark cluster, I can just do this from the GUI as long as I'm running my Hop GUI on the Spark master. If I'm not on the Spark master, this is going to be a problem, because you need to basically run Spark submit on the master. But let's just try this for a second. Let's see if anything is moving here. So surprise, something is showing up here. The Spark run configuration, and it will start doing all sorts of cool stuff. And this is pretty much running. It's not going to take too long to do that. Uh, so that's one way of doing this, and it's already done. So yeah, congratulations, Spark. Um, Another way of doing this is actually documented. Let me just. Oof, sorry, Spark is consuming a lot of my CPU. So if you go to the user manual, and yeah, you can go to metadata types, run configurations, and Spark. And so I documented um, how you can do this with Spark Submit, how to generate a fat jar. So you don't need to take notes from this thing, right? Um, Incidentally, with minus driver options, you can specify paths to variables that you might use in your project. But essentially, yeah, you can do this Spark Submit then. Yeah, anywhere. I think I had like a temp folder created here where the output is coming. Spark submit. This is just history. I don't want to retype that. So yeah, Spark submit. You specify the master again, the same URL. The class is main beam, and this is the class that you can use to submit stuff with Spark submit or Flink run, which is similar. I did like Flink in a previous occasion. It's very similar. They have a similar syntax for running things on a Flink cluster. The fat jar that we created is the next argument. The pipeline that I want to run, simply a reference to the pipeline. And since you also need to pass a file to the cluster with the metadata, because now we're completely disconnected from the project that we're using here. Again, we have a similar thing like export the metadata to JSON. And all the metadata that you have here will be exported to a single metadata file. In our case, this is yeah, a JSON file without too much fluff about it, but all the things that you need, the fat jar that we defined, all the things that is needed and on the Spark nodes basically are going to be exposed. So at that point, you can just run this, and again, we can then follow progress on the Spark master and see what's going on. There you go. In this case, I'm giving it 4 gigs per executor. Similar result. It's going to take a few seconds. It's only 10,000 records. Now, obviously, this is not supposed to be a Spark tutorial. Once you go into hundreds of gigabytes, terabytes range, there's a lot of stuff that you can configure in Spark. So look up best practices, go over the documentation. Don't do as I do and just install it like as is, right? Um, you know. Uh, so yeah, so there's that. Uh, I think that should be over and done with soon enough. And the output is going to end up in this folder. If you have, if the system is working, I'm taxing it pretty big. You can see temp files in here and say like, okay, you can actually see the output files being produced. So uh, it's not like you're running completely blind, and the Spark GUI itself gives a lot of information. It's actually pretty detailed. How you can drill into all the things that are going on in the background, all the stuff that is happening. Most of the times when things go wrong, it's happening because yeah, this is a simple file, and all of a sudden Spark wants to allocate 500 threads and then it needs to re-aggregate and it starts to run out of memory, stuff like that, right? So that's not the tutorial I wanted to give here. All right, let's let's just kill this, right? I don't want to wait for it. So the next thing, so these are all like simple, straightforward, batch-oriented pipelines. So complex is similar in nature. We process a little bit of data. I think, yeah, let's just take 1 kilobyte just to do a quick run. And in here, you will see that it's giving a lot more logging concerning the creation of that pipeline. And you will also see that it's squeezing the records through the various nodes. The way that we get this feedback is through beam counters. And so we know what, the amount of feedback that we can get is pretty low. So what if you're not running on the Beam master like I am? In that case, you can set up a remote execution So a remote pipeline execution where you would say like, okay, I'm running on a remote server, uh, remote hop server, and you can use the remote pipeline engine for that. And then you say on server, I don't know, I haven't created one. You will use Spark, for example, to execute, and every 2 seconds do a poll, right? Um, so that's something that you can use to run on the server, but make sure that your fat jar is then available on the master. Um, does that make sense? And then you will also get the feedback, the metrics that you get from the remote master, hop running on that remote master. You just fire up a hop server on the master, and then you will get the same kind of effect. So that's a workaround. Or you just use Spark submit on the master, copy the fat jar, the metadata, and then you're done as well. All right. So those are all simple, straightforward, um, let's say Beam batch pipelines. There's also a way to have streaming or unbounded. In Beam terminology, these are bounded transforms, the one that you see. And this, where we generate an unlimited amount of rows. I have no idea why I'm doing that. So never stop generating rows. Another one is if we read from Kafka, say, okay, we read from a Kafka stream. We want to keep sending rows to Kafka. So now we can do things like, okay, so maybe we can run this thing on Spark locally. So this is going to run on my Spark cluster. With a little bit of luck, we will see something pop up. And so this is going to be Spark unbounded source, which is going to keep generating a little bit of rows and send them off to my itsy bitsy little uh, impromptu Kafka server somewhere in the cloud in Germany. Um, and we can track kind of like, I put a delay in here somewhere that it's only writing 800 to 1,000 or something per second. It's not going to try to do too much. Otherwise, we might lose the connection to Google Meet. Um, and so um, somewhere else in the cloud, we might want to read from it and aggregate every 60 seconds with a window. Because once you have a streaming pipeline and once you have an unbounded data source in there, your pipeline becomes streaming. If you don't have a streaming pipeline, if you don't have a streaming, you can still make it unbounded by adding a timestamp and saying, okay, I want to add this timestamp, the system date or whatever, to it. But in any case, this means that we're going to aggregate in a fixed 60-second window. And then every 60 seconds, I'm going to write this data set read from Kafka using window write. So all the records that I'm getting every 60 seconds will end up. And so this time, I'm going to use a different engine just to show the versatility of this system. And I'm going to execute on Dataflow. On Dataflow, I'm going to use the exact same fat jar. I'm going to say I want to store the binaries. It's going to stage the whole fat jar in the cloud. And I didn't want to change my fat jar earlier because Google runs a checksum on it, and if it's the same, it's not going to re-upload. But the first time you run anything on Google Cloud Dataflow, it will actually upload that couple hundred megabytes into the cloud. And so this is where my binaries go. This is a standard small instance, right? Costs next to nothing on the East Coast. And um, so I'll talk a little bit later about this. Let's fire this up first. Um, so if we go to cloud, uh, Google Cloud Console, something like that, right? cloud.google.com. You typically see like quick access or in here data flow jobs. Um, so this one is starting up. Read from Kafka, and as you can see, it's picking the same kind of main blocks that we had in here, sort of, right? Not completely the same, but sort of. And there's an extra parallel do for the window info, but other than that, it's the same. Some transforms expand into multiple. And Google Cloud Platform Dataflow is a system where the Spark is already up and running, and then you can run stuff on it. In this case, the Dataflow execution engine is actually instantiating on the GCP Docker Kubernetes infrastructure. So it's starting all sorts of workers. And so now the latest status is that it's raising the number of workers to 8 so that the pipeline can catch up with the backlog and keep up with its input rate. So it's going to try to scale so that this transform, the reading from Kafka, is always going to be pretty much empty, right? And it's going to do that in a safe way. So if you look at the Beam API or Flink or Dataflow or Spark, they basically push blocks of data through the whole pipeline, and then when everything is safely written without errors, it will do an acknowledge to the Kafka queue to say, hey, this is processed correctly. It's actually pretty neat to have these complex engines that do that sort of safe processing. So yeah, so it's almost done auto scaling, and you can see that this is my files to stage, the fat jar, and yeah, you get some more information about the Beam API version somewhere. I think it's in here, 228.0, latest version. And so once this is done, again, you will see metrics pop up here. This is a sign that the instance is up and running. And those metrics then will also pop up here in the GUI. There we go. In the meantime, on my local Spark, this thing is still running nicely. We still see, it's already 14,000, 15,000 records sent off. So those things should start to run in a bit. There we go. So it's read the first 14,000 records, and where it will end up is in Google Cloud storage, because in Dataflow, in my Dataflow variables, I set the URL for the output to GS kettle Dataflow output. Yeah, it's still called kettle because that's how I started working on this. So if we go to this folder output, there's probably a lot of other junk in there, but we should see something like read from Kafka. Read from Kafka. So these files are now being produced. Every 60 seconds, we will get a new block for all the files that arrived in that 60 seconds. So it's like a window write. Works really nice. So every minute it will produce another set of 4 records. So I guess that's the parallelism that it's using. And then we can just refresh that. And so yeah, that's how these things work. So this is all like standard Beam functionality, right? Um, so what if we want to do something like read from Kafka and write to, I don't know, some Salesforce or some other output? Well, we had to find a way to merge both transactional models a little bit. And so if you look at these things, so in a streaming um, world, a hop transform could have like something like a couple of thousand records internally, but they wouldn't automatically get flushed because the API is different, right? Um, in Flink, you can actually specify, actually in Spark, in Spark you can specify bundle size. So the way that Beam, Spark, and a bunch of others and they work is using bundles. So they send you a bundle of records, and so you can have the case that, say, you have a Neo4j output transform or a regular table output transform with a batch size of 5,000, right? And your bundle size is 50,000, fine. So you might expect to commit 10 times in a single bundle. Well, what if you only get like 40 something records and it just sits there? Then I added a little bit of code to say, well, you have to wait a maximum of 1 second in this case before you flush this, before you do a commit in that table output transform, or in the neo4j output or graph output transform, or in that Salesforce or whatever, right? So in these regular hop transforms that are not beamified, that don't have a beam API. And the same is like, okay, so um, we have a buffer size internally 5,000, but wait maximum of 1 second. So this is how we merge both worlds and allow us to have great performance, because you really don't want to have a table output to a MySQL or something, some lonely server, and then being bombarded with single record commits or something like that. You really want those blocks coming in blocks of commits, in batches, but you don't want to have dangling records that have to wait another day before another batch of records comes in on the Kafka queue, right? I hope that kind of makes sense. So that's how we solved that. Uh, yeah, we added specific support for things like BigQuery, so that's pretty cool. We can read from BigQuery, BigQuery output, Google PubSub, and Kafka. Obviously, there's plenty more BeamYOs that we can support. We really need your guys' feedback to see what is needed first. For Beam inputs, this is now just a regular text file or CSV file input. Obviously, there are others like Avro, Parquet. There's a bunch of other file formats that we can easily, it's quite easy to add more. Just let us know what you need and we can do those. It also makes sense to think about creating other wrappers around existing transforms so that they can work transparently. There's a lot of cool ideas that we have about doing this in a post 1.0 after the summer period. Um, but yeah, so I think might be a great time to open it up for questions a little bit, Bart. I know I kind of went quickly through this, but yeah, I don't think it's more complicated than that, right? I don't think I forgot too many things. It's
Well, there have been a couple of questions
Okay.
in the chat, and well, we've been trying to answer them, but maybe let's just quickly walk through them and
Yeah. Great.
walk through them so everybody hears and knows the answers. Um, First question, well, is unit testing pipelines only or also workflows? That's pipelines for now, and I don't think it
Well,
makes
yes and no.
workflow executor. Yeah.
So yes and no, in the sense that obviously, a Beam pipeline doesn't really have a workflow engine capability. That being said, if you have a workflow, suppose that you want to do this one, you can easily uh, add this into your workflow. It's actually quite useful to do because, as a lot of cases, you might want to copy some data around on GS, clean out an output folder, uh, clean up temp space, copy some reference files, and for a workflow, that's really cool work, right? And then you can just say, well, I want to use Spark here to run this thing, or Flink or Dataflow, and it can fit into whatever process that you have. You can do this on the command line as well, right? Um, so in that sense, it does work. In theory, it should also be possible to do things like use a workflow executor in a Beam pipeline and stuff like that. But yeah, I have to see a use case first before I try to make stuff like that work. We would be using the Hop workflow engine in that scenario. But since all the code is available on the Spark nodes, in Dataflow, on Flink nodes, yeah, we could do that. There's no reason why we couldn't, why we shouldn't, or yeah. Um, but it's usually more an issue with managing the world around that, managing are all my workflows and pipelines available to the context of where I'm executing all these sub pipelines. Um, so managing that is a little bit tricky. Yeah, another question?
Support for various data formats. We looked at CSV, and the question is about is Parquet org
Yeah,
supported?
yeah. So I have all the plans in the world to add those. I actually started uh, doing further pluginization of the whole Beam code base. Now it's pretty monolithic. Um, yeah, adding more YOs is really not that big of a deal. Just create Jira cases for those, and we'll start cranking them out. Um, because it's if you look at it code wise, um, GUI wise, this is like half an hour work, and the rest is basic covered by the Beam API. It's just a little bit of metadata juggling, basically, right? For Parquet, there's the Beam Parquet YO dot read. For orcs, the same. For Avro, it's the same. So it's not like we need to do a lot of coding. It's just a wrapper. There's a small metadata indicator that we have in our Beam transform handlers. Let's say this is an input, this is an output, or neither. This is a generic manipulator, and then it can build a pipeline. It can connect the dots, so to speak, and then you have the Beam pipeline. So just create the Jira cases. Let us know, and then we can usually pretty quickly provide those, because the libraries for all those things are already available.
Mhm.
Great question. Yeah.
Next question was about support for AWS EMR. Um,
Yeah.
yeah, shouldn't be a problem, I guess, but I haven't tested it myself. Don't know if anyone has.
Yeah. For these file protocols, right? Um, the there is a little bit of a discrepancy. So if you look at the file protocols for Beam, like GS protocol, it's actually not Apache Virtual File System. It's from Beam itself, apparently. I think we should start that conversation with them at some point why they're not using VFS. But I guess it's got to do with the way that input files are split up, and the way that Spark and the other engines are doing that. Uh, so for GS, HDFS, and I think S3, I'm not sure. That should be available out of the box. Um, as
Yeah,
part of the Beam and engine.
EMR is Elastic MapReduce, the AWS service to run Spark,
Yeah.
Spark basically, and I guess that depends on the Beam support. See how well that works with the Spark runner.
Yeah, I don't think it should be an issue. I think we can just test
No.
that if you have a if we have a minute
Um,
to spare, or if you have the inclination to test that, it shouldn't be an issue, right? Because running on my Spark or on another Spark, it shouldn't really make a difference. Um,
Matt, I was just going to say real quick, yeah, I work at Google in our professional services, and Dataproc is the same way.
mhm.
Spark runtime's available. So
Yeah.
yeah, I would imagine, yeah, just make sure you have the right version of Spark deployed on a ephemeral cluster,
Yeah.
and EMR or Dataproc would probably do just fine, or Databricks for that matter, right?
Yeah, exactly. Yeah. It's just that, for now it's version 2.4 of Spark, for Beam 2.28. But yeah, in the next month or so, I expect 2.29 to drop, which will offer a version for Spark 3 as well. Um, I'm not sure how many people are that keen on 3 or 2, if it's still that bleeding edge. There used to be a time when everybody was on the latest point release. I'm not sure if that's still the case. Maybe people have become a little bit more conservative. But yeah, that Jira case in Beam has been done, and then we'll update our libraries in the next release so that we can have version 3.0 support. Yeah.
Yeah, it makes a lot of sense to start testing, or if anyone in the community wants to test and provide feedback about running this on EMR, Google Dataproc, Databricks,
Yeah.
then would be really great.
Yeah, we'd be happy to write up the docs or
Definitely.
or give you commit access to the docs. I think it's very valuable that this thing works out of the box on a variety of systems. I'm just testing this on a local Spark on my Linux, and incidentally, uh, I did include the Hadoop libraries because I tested with those as well, so that you can store the fat jar in HDFS and stuff like that, and you can read write in HDFS. I think you just have to configure the Hadoop home and uh, do a little bit of configuration locally, but that's about it. It should just work. The libraries are included in the runtime. So if you do then a Spark submit on the for the Hadoop master, that should work just fine.
Yep.
Next
Next.
question.
Yep. Well, I'll combine two questions. One was, can the fat jar be trimmed down or built
Yeah.
incrementally?
Yeah. So like I said earlier, everything that you don't need from Hop. So if you say like I'm going into the plugins folder and there's like transforms in here that you don't need, or technology that you don't need. We started to say you don't want Azure, you can just remove Azure. You don't need Cassandra, you just I don't need new whatever. You can just remove these folders, build your fat jar again, and then you will have a smaller. Same for Mongo, MQTT, all the things that you don't need. Now, um, yeah, maybe you can talk more about that, Bart. But our plan is to not do this manually, but actually provide software profiles for you that we can do this more fine grained later on. And yeah, the ability to enable, disable plugins, stuff like that, or keep them enabled but hidden from the UI and stuff like that. Those are things that are on our
Yeah, on a
we
wish list.
really want to do this list, even though they might not be in Jira yet. But those are things that will make our life a lot easier in the future. What we also want to do is based on those software profiles, say, okay, now I'm going to do validation. So in development, we don't care what kind of software that you're running, but in development, it's fine. In tests or acceptance, we want to throw warnings if you're running plugins that you don't expect, if you're running a Java version that you don't expect, or even running an operating system that you don't expect, if you don't have enough memory, or if you whatever, right? If you have less disk space than you expect. So these things are part of, let's say, an overarching team where we want to do more to help you out with best practices um, and make sure that you don't inadvertently come across shenanigans, right? Um, so these software validations, environment validations, these are all new metadata objects that I think are going to be easy to add and can add a lot of value to you. Uh, and I think it should then be possible to say, well, I have a certain software, a certain profile for this project. In this project, I'm not using any Cassandra, so disable all, hide all the Cassandra stuff. It might make it easier for developers to find things, right? So all that is part of what we had in mind for after
Yeah.
1.0. And then you can even say, well, if you then have the metadata that defines this is Hop version 1.1 with these and these and these plugins I want, well, then you can just envision a service along the things that Bart and Hans at one point wrote, where you can just say, well, I'm just going to send a request to the server, and what you get back is a zip file with or a fat jar with everything in it. We can automate everything at that point.
Yeah, part of a package manager
Yeah,
that updates your hop installation based on a policy, but could also build a fat chart.
yeah, yeah. And since it's all open source Apache license, that should be quite fun. Um, or even create a Docker container using that, whatever, right? So that would make a lot of sense. And then you would have exactly the minimum things, the minimum size of. But yeah, we're not there yet. Well, but it's made easier because we in Hop we split off everything that we could think of into plugins. That's why we have so many subfolders there. Um, I think was it Dan or Ditar or any of you guys that ran on a 28 meg Hop installation? uh, yeah, I think so that is possible. A very interesting topic.
Would
And
that
if
use case be for running on an IoT device, for example?
yeah, exactly, on Raspberry Pi or
Mm.
and the memory requirements of Hop itself are really really low because there's also if an internal engine is just a streaming engine, it keeps a couple of records in memory and just spits them back out. So yeah, so exactly for very lightweight work or lambdas or yeah, just have it available as a very lightweight library in any place that you might need it.
Nice.
And you also, these pipelines here, you know, this is just metadata, right? It's just an XML file. There you go. So this is just a simple XML file with some information, the order, the transforms. Now, generating the XML is one option that's been done in the past using the Java API to generate them. You can use ETL metadata injection even in a Beam, Spark, Flink scenario. And metadata injection means that, well, we don't want to define the fields of the files up front because I have 1,000 different file formats in HTML, in 500 different HDFS folders, stuff like that, right? And I want to do a normalization exercise or calculate, for these like bursting exercises. We have, so these, it's just metadata manipulation at some point. Not all of it has to be manually dragging and dropping and entering in a GUI. It could be an API that generates the metadata and then executes it. So yeah, great questions. Amazing. Any more? All right.
Matt, one more that I've got.
Sure.
Coming from, like, at Google, we have like Cloud Data Fusion, open source CDAP, right? And there's like a deployed web-based like hub, if you will, where you can see your pipelines with a visual view.
Okay.
And I'm trying to understand here. I mean, like, this seems like a client desktop like design runtime, right? This is like you're generating it and you're sending like the work off to a runner, which I like. But like from an enterprise standpoint, is there some way to have a library of the deployed pipelines with like a visual view and like an IDE to potentially like edit them over time?
Yeah. So Hop is a Java API basically, and we have an API available. Well, obviously, so all the everything is open source, right? So
yeah.
But yeah, you can create your own plugins. There's a lot of stuff that you can do, and if you you can always like ping us, and we can set up a separate session for that. It's actually a great topic for another session. If you just look at these things, the way that we do integration testing, for example, on Jenkins, those are all great topics. But so that's one aspect of, okay, so how can we do the editing of the metadata differently? Obviously, we also have Hop Web available, and
this might have been what I missed, like Hop Web.
I think. Does anybody know what the command was for Docker?
Yeah, but depends. Well, Docker images to.
I can just look it up. Hans, can you look it up and paste me?
Chat, Matt, chat.
Okay. The chat of the meetup?
Yes.
Okay. It's been a long day. My son is doing an internship and he has to get up at 6 a.m. Anyway, so I think I need to stop my slave here. I'm gonna do a violent shutdown of this. But yeah, so we have a project in the making. It's called Hop Web, and so Hop Web is exact same user interface as the fat client, as the full client, but running in your browser. Pretty much what we were discussing earlier is it needs OAuth, some authentication on top of that, Tomcat. or some other shielding, but that's so localhost 8080 will give us this UI.
Nice.
But other than that, yeah, the samples are not yet included in this version. But yeah, the GUI itself is very comparable. Beam input, I think you can sort of like perceive that it's the same kind of thing. So this is what we're working on. I think we're close to parity. There's still an issue with keyboards, shortcuts here and there, and maybe some polishing up left and right. But yeah, we're getting close to something that actually works. I was just about to say, but yeah.
Matt, what are you thinking with
Go ahead.
the Web Hop? You know, back when we were doing Web Spoon, session management and having like multiple users kind of have an environment. What's your thinking on how to manage that?
Yeah, so the way that Hop Web, the big difference is that Hop Web runs off the exact same code base as Incubator Hop. So it's no longer a fork or anything. It runs off the same code base, and we had to sprinkle a few if-thens left and right in the code, saying like if it's running in Hop Web, then this or that. But every tab that you open here is actually a different session of Hop GUI that's actually running. So it's already completely isolated from each other. So if you create workflows here, it's not going to be affected. You can there's this complete isolation, despite the fact that they're running in the same JVM. There's like complete multi-tenancy for as far as Hop is concerned. So they're running different variable spaces, different everything. So it's completely isolated.
Cool.
The only thing that you so you can have different projects open, different environments configured, everything is separate. Yeah. So that obviously took a bit of work, but we did it because of Hop Web, because of architecturally we wanted to be as clean as possible. Yeah.
And for Hop Web, we see like two use cases, like the one big machine with multiple users, or you say, well, we create a login portal, and when you log in, we'll spin up a Docker container for you personally and redirect you to that container that you're actually running on separate resources as well. But these are just IDEs. There's nothing concrete about those yet.
Yeah. What's cool is you get the Git integration now, which is going to kind of be how you save state built in, and you're not trying to deal with making all your file or your saved metadata remote, things like that.
Yeah, and the third use case that I can see as well is exactly what you said earlier. If you have something running in an existing environment in your enterprise or on Google or anywhere, and you say exactly, something went wrong. Something always goes wrong, right? You say, okay, show me the pipeline, and so that you can just click on something and it pops up Hop Web, even if it has to start the Docker container on the fly, or if for the first time that you do this. So there are multiple angles where I think this could be very useful.
Have you examined like Google Cloud Run here? Deploy the Hop Web there, and then it could auto scale.
Yeah, exactly. Yeah.
And I was also thinking
for Web Spoon, I think there's still a blog post out there somewhere where somebody used Kubernetes to auto scale the number of web front ends, basically, depending on the number of users that they had. But we like the one user, one container paradigm, because you have to remember that if you're developing things that, sometimes like data orchestration work, pushing millions of rows through a pipeline to test, it can be quite CPU intensive. and I'm not really certain that it's very comfortable to work with a lot of people on the same container, if you know what I mean.
Yeah.
Yeah. And since it's only, we cleaned up we cleaned up the API to such an extent that I don't know how long did it take. 9,000 milliseconds is a couple of seconds, right? It feels like it's only like 5 6 seconds before you have your container with Tomcat and everything up and running. Um, so
I
yeah.
can see that multi-tenant environment
Hmm.
making more sense if you're pushing down to other engines. Like you'd
Yeah.
almost disable the direct runner,
Yeah.
right? And then like be pushed into Dataproc or Dataflow or Flink, whatever, right?
Yeah.
And that could be like a data team's like place to
Yeah.
just like trace. Here's deployed jobs to production. I could see like the visual pipeline, and then it'd be really cool if there was linkage to like Dataflow's
Mhm.
graph, so you could see
Yeah.
like version of like logging and everything versus like how it's presented in Hop.
Yeah, absolutely. Yeah, and,
Mhm.
and your feedback, like I said earlier, we're still in we're opening up new possibilities. So other possibilities that we thought of was like, okay, suppose that you want to work that at Neo4j we're doing lots of proof of concept work with customers and stuff like that. So what I would start with is like an empty GitHub container, a GitHub repository that I create, maybe a private one or whatever. I should just be able to give my key or generate a key for that GitHub, and then it just starts a Docker container, checks out the project, clones the project in there, because we integrated Git in here. So if you have a Git folder in here, so I can do push pull, commits, rollbacks in here. That's all I need, right? And then I have my work in that Git container. And when I'm done, I should just be able to hit a button somewhere saying like, okay, I'm done programming. I don't need the container anymore. Shut it down. And everything that I have is still in Git.
Yeah,
Right?
that's a lot how Looker works.
Yeah.
You get a sandbox like when you're developing like your own, and then you can deploy to a master branch all
Mhm.
within like the UI. And
Yeah.
it's pretty darn convenient.
Yeah.
Mhm.
And then this came up in the other session the other week is obviously integration with the logging backend that we have. So the pipeline logs, for example, it would be cool if we could um, integrate that with we can already write to GS, but maybe
Stackdriver.
Stackdriver, just write
Mhm.
like a Stackdriver output transform in here so that it integrates with the rest of the stack. Um, there's we're not there yet, but there's plenty of potential in there. So if you have any requirements, we'd be happy to work with you guys on making a proof of concept or whatever. It's a lot of fun to do these things. That's the most important thing.
Yeah. Well, yeah, I mean, so I'm like a cloud consultant slash like we have like more technical like engineers that are called strategic cloud engineers.
Okay.
I can do so much more with this tool on Beam than like native just like Java. And like when we
Yeah.
hire skis, like we're like, oh well, you should be able to crank out Java, Python or Python Beam
Yeah.
pipelines. And I'm
Yeah.
like, there's just so much more of a wide net of people who could like be effective if this was like widely adopted, right? So I'm really impressed and hope it continues to move forward in the way it seems.
Yeah, and it's always like these blends that trip you up, right? So if you think about these APIs, whether it's Python or Java, um, this is not something that I invented, but in the data orchestration world, it's fine if you have one or two or three technologies, but once you have three, four, five, you have to deal with the combinations, and it's the permutations that trip you up. You have to learn more and more APIs and how they work together and juggle libraries and whatever. And so for the simple cases, it's probably easier to just write a little bit of Python. We see the same at Neo4j. We see the same in a lot of cases. But once you say, well, I want to have this unit tested, have different environments for dev, production, whatever, then it becomes a different ball game, right?
True.
Yeah, and so then you say, well, I have all the data, but there's like this Excel file that people upload, or Google Sheets, right? I have a Google Sheet somewhere, and I want to sideload that data into, and then you want to be able to say, well, I have like a spreadsheet. I don't know if that would work, but these are the sorts of things that we think of as should be trivial, but hey, it's not that trivial to do once you start doing it with a Java API. All of a sudden, you need to drag in another couple of libraries, another whatever, right? So if I look at the Beam mailing list for the user Beam mailing list, I see sometimes things pop up like, how do I read data from Salesforce? How do I combine a file from Amazon somewhere when I'm running on Dataflow? And with Hop, you can do that. So the VFS driver should work also when running on Dataflow. I actually tried that.
Yeah, I just came across a new project and it's called Airbyte. Have you guys heard of this?
No, sorry, not yet.
Okay, well, it's open source as well, but like they're all about having like a bunch of connectors that are container based, and then like enabling you to kind of like create pipelines, so sort of like Fivetran. So yeah, I mean, it'd be kind of cool if you could blend in other open source sources that might like be container based and like plug
That's a great idea, actually.
I'll send into the chat a little bit of
we're really not opposed to even integrating other engines because we just did that, right, with Beam, Spark. We're more about the best practices, the metadata manipulation, the visual design, and give the users a great experience in doing that. That's what this is about. Yeah. Hey, any other questions?
Yeah,
I hope
go ahead. Plenty of questions. Next one was, well, I'll combine a couple of questions. Support for custom transformations written in Scala and Java code. So user-defined Java class is one for Java code. Python has a CPython plugin, and Scala is the third part of that question.
I think this question also came up on the Mattermost channel earlier.
Yeah.
I would love to have a Scala plugin example. I don't think it would be too hard to do, actually. In general, the Java API for plugins and stuff like that is pretty simple. We kind of like isolate data manipulation from one transform to another or from one action to another to make sure that if you mess up something in one transform, it doesn't affect the rest. So that means that if it runs on the JVM, it's fine. I would love to work with anybody that wants to write a Scala plugin. Yeah, absolutely.
Question was about more advanced Beam windowing, triggering. Hans and I pointed to the window transform, but I guess there's more that you can.
Yeah, so the windowing, so we support sliding session global windows plus fixed. Triggering, that's a hard one, right? Again, if you have a specific use case, I would love to start from that. I looked at it sideways and I couldn't really find the use case immediately. But remember that we start from the metadata, so we already have the Beam pipeline. We already have 99% of that code. So adding a trigger capability, maybe saying like, if some condition triggers, then we execute something. It could be a script that we run, or it could be run another pipeline snippet, or it could be, yeah, but I would love to hear ideas about how that could work. Use cases are usually the best way to start in those scenarios. So, but yeah, I would love to add triggering and yeah, and other stuff.
I mean, maybe if you could, I mean, like some of the triggers that we have is like, file drop on GCS,
Yeah.
on file store trigger a pipeline, right?
Yeah.
So if like that Cloud Run example came up, like you had a containerized version of Hop with like a config, like, basically a pipeline definition, it would like drop a file and then like it fires that up on, Cloud Run, like Jeff was saying earlier. It'd be like batch oriented, right?
Yeah, we already have a Docker container, an official Docker container that you can execute your pipeline with, and you can also use that to run your Dataflow work. So that shouldn't be too much of a problem. There's maybe a little bit of plumbing, but yeah.
It'd be pretty much, you could pull it off serverless the entire way, like,
yeah, exactly. So you
have any infrastructure running, which would be pretty awesome.
We already had someone that put Hop on the AWS Lambda function. So I'm guessing we could do the same, like use the UI to define a Google action a function. Sorry. And,
yeah. Functions, or like, and what I really love about Cloud Run is it accepts Docker containers. To be more native,
Functions you can only run for 8 minutes at a time.
Yes, but true. you could create a function that just triggers something on Beam, right? So
that's true, and then it would end, right?
Yeah, and then I think we did have a discussion internally. We had a couple already. Like, how much should we do of that external work as a project? But my impression is that the more examples that we can give, the more docs that we can write around that topic, the better it is. So that people have ideas like, oh, I have all these building blocks like Docker containers, and how can I puzzle them together, right? How can I now run with that Docker container a Beam pipeline on Dataflow, for example, and then you can fit it into other tools and say, okay, if I have a bunch of files that drop in my GS folder somewhere, then I can start this Docker container with this with this command, I guess, right? A couple of variables that you set, and maybe some fat jar that you point to, and that should be it. Yeah.
It'd be kind of cool to have an examples section of the repo, kind of like you already do, but it would be a little higher level. It would be like,
exactly.
Here's an entire deployment of like, I don't know, how to deploy Cloud Run componentry, Dataflow componentry, like the whole gamut of like an end-to-end, right?
Yeah. So that's where we had the discussion. How much do we want to do this as a project, and how much do we want to have other people do that, right?
Yeah. I mean, I get some time with my role to like do, Medium posts and stuff. So like to like show this as a tool, to like showcase some of our products could be cool, but I'd want to like, share it on the Hop side as well, as well as on the Google side.
That would be great, actually.
Yeah, but for us, to give an example, so at Neo4j, we're quite successful with Neo4j Aura, the cloud offering that we have on GCP. And so the question then becomes for a lot of our engineers, how do I now load data And exactly what you were just describing, like, okay, so I have a file come in, I want to automatically load this data into Neo4j without having to instantiate, let's say, a virtual machine or something custom built, because that's against that cloud idea that everything is automatically managed from the Neo4j side. You don't have to do anything. It's completely managed by Neo4j, backups, everything you want. But now all of a sudden I have to manage my own VM, and that just doesn't fit right?
Yeah.
So yeah, for me, it's quite important to find answers that really work well and are, not that hard to set up and maintain, especially, and monitor, and So I'm completely in agreement there. We should create the examples and get show on the road.
Yeah. Actually, I attended. So I work in our public sector professional services group, and you guys had graphs in government yesterday. Neo4j. It was like a morning session. It was awesome. So look forward to more partnerships there, because like graph, like data modeling is like totally up my alley. Something I want to do a lot more of.
Yeah, and the Neo4j plugins since version 0.70 are part of the standard build, so you can just play with it.
Cool.
And so now that I'm on the topic, so I don't think anybody will mind me doing this. So Neo4j Aura is going to start giving out free instances for people that want it. So neo4j.com cloud Aura free. You can put yourself on the list. So every developer will get like a small instance of Neo4j to play with. So we're not there yet, but we are going to do this. So put yourself on the early access list if you want to play with it. But it makes it easy to do these clouds integration tests and just play with these things. Yeah.
Hey, Matt, I know we're close to time, but could you come back to the integrations and things you were looking to do with Airflow?
Yeah, so so if you look at the workflow engine, right?
Yeah.
So typically the stuff that you do in here are, check if a folder is empty.
Right.
See if a file exists. Exactly, send off an email if something goes wrong. Send an SNMP trap. Ping a host, right? So you can do things like passive checks. I want to ping my server. I think I have some example here. What am I talking about? I have too many projects already. I think so. This was the loader for Aura. So this thing does like, okay, so I'm gonna check if my host name is up and running. I'm gonna check if the Aura instance itself is up and running, because this is like pessimistic PDI. I used to call it pessimistic data integration, right? I'm gonna assume that it's not there, and I'm gonna assume. So this is the sort of stuff that you do, right? If this is right, then I'm gonna check the next thing. I'm going to log my configuration. I'm going to delete some temporary files. Then I'm going to load some nodes into Neo4j. Then I'm going to load some relationship, log some statistics, done. And these are great green arrows. Execute if something is right, then go on to the next. This engine is a backtracking engine. So if you branch off into different possibilities, it will do like a backtracking thing. Very simplistic. There are other engines because this is just XML. This is metadata, right? You can think of a Apache Airflow variant that says, well, I'm just going to, in the worst case, generate code that does a ping, right? Or stuff like that. So there are some possibilities. Or I'm going to build Airflow plugins that allow me to run Hop code on Airflow. That's another possibility.
That's what I was thinking. Yeah.
So that's
just building an operator, right? So you've
yeah,
got.
so that's exactly what we did with Beam, but then for Airflow.
Yep.
And let the sequence of things handled by Airflow, but do the individual tasks. And again, if you have a fat jar or something, that you can just say, hey, I'm going to expose this so that Airflow knows what we're talking about when we say ping Neo4j or check a Neo4j connection. So those things are very much in the realm of possibilities, like we did with the pipeline engines. We can now have multiple workflow engines. Right now, we just have the local and the remote delegating workflow engine. But yeah, we do have a plan to create more engines. And yeah, specifically, Airflow was mentioned in our incubator proposal for ASF. So that's why
So
we changed the terminology.
the workflow would kind of compile into a DAG.
Yeah.
Yep.
Cool.
Yeah.
Is the new Hop? Did you guys figure out the parallelism aspect? Like, 3 jobs that converge into 3 workflow steps that converge into one, race conditions, that kind of stuff.
Yeah. So.
Or you have to do the sub job trick.
Yeah, you have to do the sub workflow trick. Yeah, that's still it's one of the annoying things, right? So again, for because so many beginners run against that. I said, well, this is the backtracking engine, so parallelism was more like an afterthought of this thing, right? So for folks, I don't know. So suppose that you have like one, you do something, right? And then you have a pipeline, and another one, and another one.
Yeah.
And you say, I'm going to run them in parallel, right? So you just do them in parallel. Okay, so the backtracking thing means that if I have other things, like another pipeline here, these things will also be running parallel. There's no GUI way to say, okay, so this work is supposed to be running parallel together. So this is why the large dialog box popped up to say, if you want to stop after the 3 pipelines in parallel are done, you need to push them into a sub workflow, and then that issue is done. And push all the parallel work that you want to do into a sub workflow. But now that we have the possibility of creating new workflows, yeah, all options are on the table, basically.
You can kind of solve it because an Airflow DAG handles that very elegantly, right?
Yeah. Exactly.
That's
so
cool.
yeah, at some point, if that works fine, then you can just switch to a different default for the standard workflow engine, and that would be it for us. Yeah.
That's cool.
Pretty straightforward, I think. Great questions tonight. Any others?
A couple of last ones. One was about converting legacy Pentaho plugins or legacy Pentaho sources.
So yeah, great question.
Yeah.
Porting kettle plugins. So obviously we've done 400 something.
Yeah, there's not that much to port left now, but
there's not much to port left. And we would love to help you out. There's some basics. In general, you'll see that the code is all of a sudden a lot cleaner, more, yes, a lot cleaner, a lot simpler. But yeah, we did rename a lot. We did, get rid of the interface and went to a more modern I in front. This is usually very straightforward. Plus, you have 400 something examples to start from. Plus, we would love to help you out. Just join our Mattermost server, it's free, or join the developer mailing list on the ASF, even better. We would love to make you a contributor or a committer. Everybody's welcome. Yeah, we are growing quite fast. We are growing as fast as we can. Right now, we are trying to stabilize everything as much as possible. We're adding documentation, integration tests, but adding a new plugin is virtually risk free because everything is nicely isolated. Everything is a plugin in Hop. So I don't really mind adding more plugins to Beam, or that's not where the risk is. We just don't want to mess with the core API at this point because we want to really have a stable 1.0. I think it would mean a lot that we have that out there. A lot of people are waiting, but the code base is 20 years old and actually already quite stable, and integration tests are running, and we've come a long way. Yeah. Yeah, you had another question, maybe?
I think, well, there's one from Nick about I'll say that again, Protobuf decoding. Serializing to Protobuf is what I understand. Right, Nick?
You just need to read the Google code base there, Nick.
Yeah, well, I knew that to PubSub, Protobuf, schema versioning is coming. So it's something that Kafka has with its own Kafka schema registry, right? And this is really useful over time, right? So you can do the same thing with Protobufs. And so we're talking about Orc and Avro, and just like being able to decode a lot of the compressed formats, or it would be helpful.
So what we started doing for those is so we have pluggable data types, and so we started thinking of doing JSON as a data type, but also the things like Avro, where you have a bunch of values basically comprised in a single value, right? And so then we can create transforms that can pick and choose or automatically convert. So right now, for a bunch of the Beam code, this is done through functions in the background. But yeah, we want to expose this more to the user, so that you say okay, I have an Avro data type coming in. I don't want to take everything from Avro, just these 3 fields, for example, and map them to standard Hop fields, and then write them to another file format. So I think we would want that flexibility. So extra data types, Avro or other encapsulating data types, are quite easy to do. Again, it's not that big of a deal.
Nice.
Yeah. Again, just create a Jira case saying, hey, this would be a great idea, and this is what I want to do with it. Typically, what we also want to do is say okay, we want to convert lazily, right? The reason why JSON would be great instead of a string is that, well, if I have 4 JSON operations, this adds a property to the JSON object, this adds another property. You don't want to do string to JSON to JSON to string to JSON to string all the time. It would just probably do more work converting to string from string to JSON than adding a couple of properties, if you know what I mean. And the same for a lot of the other data types. You probably want them to become as lazy as possible. Not convert to anything else, and that is why Avro and a bunch of others are just interesting to add. Yeah.
Nice. Thanks for that.
Fantastic questions.
The last one I'll reiterate. I think this tool's you got a lot of plugins from 20 years of history, and that's amazing.
Yeah.
But there's all these vendors now in like open source projects like the one I sent before that are making it easier to do SaaS integrations. And if you guys could couple that together somehow and then like be able to like apply transforms and then apply the power of like distributed, data loading, I think it'd be pretty amazing. And I'm thinking of like a 5-tran like connector, where it's like they'll figure out going to Salesforce, but then like they could like somehow couple into a hop pipeline. That'd be pretty amazing, right?
Yeah, and there's nothing blocking us from doing that. It's just the architecture is in place. It's pluggable. We can read from pretty much or write to pretty much anything, right?
Right.
Yeah.
But I think it's like a developer, when you're considering like NiFi versus stream sets versus like this, you often are like, how many sources do they have? How many destinations do they have when you make your decision, right?
That is true. And even in the case where you do a lot, where you have a lot available, you're still never going to do everything. There's still going to be room for specific verticals, for certain support for certain apps or whatever, right? But yeah, I think what we wanted to build was a metadata and plugin management system with a clear focus on things like all the best practices, like version control, projects, environment management, unit testing, those kind of things, right? And then everything else comes naturally almost. We can add more plugins, more functionality, and I don't have any objections to.
I mean, 5tran's like a growing company. It'd be interesting to just like pitch them and say maybe you build a source kind of like integrator connection to your stack, and then you get more customers, right? Because like people
absolutely,
on stack will be like, oh yeah, I'll use 5tran to get to Salesforce, and then we don't have to build something here, right?
Yeah, and it's the same for we said earlier for Airflow. So if you guys are in the market for a visual designer for this, and then if we are like 6 months further with Hop Web, all sorts of things pop up and open up, right? Possibilities present itself because the state just naturally progresses.
Right.
And I think that that sort of attitude is also why we wanted to be an incubator project at ASF. We're not a company, we work for different companies and we have different interests, but it allows us to work together in a constructive and collaborative fashion without any tanglements or difficult political situations, right? So
totally,
that's been really positive for us. Everybody's welcome. 5 strands. Yeah, I took note.
Yeah.
One last question, and then we can call it a day, I guess. And last question was if we have any OCR plugins or RPA, robotic process automation to read PDF invoices, for example, convert to JSON, read audio, and convert that to featured data.
No, on most. I once had like this Apache Tika plugin though that we can port, and Tika does like most file formats. It can read the text version of the content and provide a lot of metadata from the file, like PDFs, Excel, whatever. For audio and so on, again, all these things are possible, or even video and images. And I once came very close to actually doing that, but yeah, we didn't really have a use case for it yet.
Well, and I think the use cases are there. but we just didn't have the time. And while doing all the cleanup that we did, building the new Hop GUI and everything that came with it. But now that 1.0 is getting within reach, a couple of weeks away, maybe a couple of months, but we will start working on building new plugins, and this is definitely really interesting. So these are things that we can start focusing on.
Same for GIS, for example, GIS plugins. So I heard from Silvana that he's interested in porting the GIS plugins that he has. But I had this use case a long time ago. I knew somebody that took a lot of photographs from Als Carnaval here, big events. Well, it used to be before Corona, and they had something like from a whole bunch of photographers, 500,000 photos or something like that, pictures, images, all different file formats, different cameras used, different lenses, settings, lights, file formats. And so a lot of media that had to be normalized to be put on a website, for example. And there aren't really a lot of great tools to do that. So extracting the metadata, that could be a transform that you can just say, okay, I'm going to pick up the metadata, normalize, clean up the image, put on a watermark, stuff like that. Could all be like very simple transforms. And the image could be a data type, and you could stream it. You could put it through a Spark transform, you make it a transform that runs on Spark or on Dataflow on large machines, and have it done in a jiffy, right? But yeah, I think, yeah, concrete use cases are what drive these innovations, and then we can start from there. Usually the libraries to do these things already exist, mostly. That's my experience. Java is a pretty rich ecosystem. So creating a little bit of GUI around those and wrapping them up, making them available to all these engines is then quite easy.
Matt, I was having a thought on that one, and like, you know, we've done a number of these sorts of like workflows on GCP where we use our Vision APIs to go do this, bring back the metadata. So what would be kind of cool here is like, imagine you're going through and you're getting like a list of images to process, and Hop's doing that, right? And it's kind of like creating you a array to process. And then you could have like two options. One might be go to Google Clouds or some API that does this like OCRing for you. And it returns the results that Hop would parse and like get to a database. The more, an even more open source friendly way might be to have like an execute container step for each row, right? Where you could basically run a Docker like program, you know, for every row, and then you're gonna have, I guarantee you could easily find an OCRing Docker container out there like right now.
Oh yeah, probably.
Right? So I don't know if that would be too hard, because it's sort of that same concept of push down engine work, right? Like, you know, this, you know.
Yeah, very possible. Very possible. And I guess, you know, we went through great lengths to make sure that, you know, like I said, we have Docker containers for Hop. You can embed this. You can run these pipelines through a Java API, through a script, on any kind of on Jenkins, obviously, you know, and we have the examples in our own project, the integration tests, whatever. So it becomes, you know, if you look at other data orchestration stacks, sometimes you need to set up servers, run this, run that, configure repositories. We specifically said we don't want to have any of that because of this specific reason. You want it to be easy to be part of another stack, right?
Yeah.
Yeah. All right. That were really cool questions.
I'm gonna go download the latest version. Excited.
Yeah, we can't list the development builds, the latest builds. But yeah, we have them somewhere. Maybe Hans can paste them in the chat. Paste it in the chat. We build continuously. That's the latest, greatest.
The download link is in the header of the dev channel.
Yeah.
Although I must say that like 0.70, everything that I demoed right now for Beam is part of 0.70. There wasn't anything I had to tweak or fix to get any of the samples to run. So it should be good. But obviously, yeah, we've been fixing a lot of small bugs, left, right, UI things. Yeah. as you can figure, you know.
So you're version 0.99.
Yeah,
Were
0.99. Like I said, we are working
So
towards
close.
the 1.0.
Yep.
Bart has been doing tremendous work on the documentation to make it final, complete. Well, it's never going to be complete, but at least that all topics that we can think of are covered. And I think Hans added more integration tests today, which is great. And yeah, we have Sorrow that is donating samples every day. So I think it's moving more and more towards a solid 1.0.
Yeah, so the idea with the 0.99 is that it's actually more like a release candidate for 1.0. There won't be much changes between this one and 1.0. It's just like to find those final small things.
And the idea is Apache's going to sign off, and 1.0 will bring it out of incubation.
No, not specifically.
Okay.
We yeah, it was actually more painful than I thought to do the 0.70. Maybe Hans can talk more about that because he did it.
So, well, yeah, to become an Apache top level project, they do not, well, obviously your code has to be in line with the Apache license, and that's what they're obviously checking when you're making a release. But the main requirement to become a top level project next to that is to have a active community, and I think we are getting there, and our community is growing. So after 1.0, we will start this graduation process and try to become the top level project.
It's actually been interesting because at one point I did the Cassandra plugins, and it dragged in an LGPL library, and so I filed the bug reports at the Cassandra project. I said, hey guys, Cassandra all Maven drags in a LGPL library, which is, by the way, already from 2011 or something, or no, it was like 12 years old or something. And so, yeah, but we don't have a dependency, but you know, it's like, those are the sorts of interesting discussions. But we had to remove whole swaths of our code, rewrite whole blocks of the kettle code. We had to throw out a lot of stuff that was not appropriate to package into Apache software. Because it was LGPL or dependencies or this or that. But yeah, I feel a lot cleaner now, so I don't mind. But yeah, it's been a lot of work, but now, yeah, we have a solid foundation to do 1.0, and the graduation, that's going to be great, but it's going to be a consequence of the growth of the community and the releases that we do, not the other way
We're
around.
getting close there as well. A lot of the roadblocks for graduation have been fixed. We have the licenses in order. Name search has been completed, so there are no copyright claims that could endanger the hop name. We went through a couple of releases, so we're basically getting there as well.
Yeah,
that's awesome.
So yeah, let's say maybe second half of the year that we will have that process going on or already taking place. But yeah, the votes and everything, it takes more time than, yeah, because they're all volunteers that they're doing this. But yeah, I don't think we're in a rush or anything like that. Yeah, it will be done when it's done. It would be great to be a top level project though. Kind of like legally gives it a different status.
Yeah.
But community wise, yeah, that's fine.
It's making it easier for me to sell that
Yeah,
we should
absolutely.
use it,
Yeah, absolutely.
because me saying, when I started at my previous role doing GCP integrations, I'd be like, why are we spending 2 weeks writing Python connectors for Oracle? Like, why don't we just use something? And I go, Pentaho, and they're like, Pentaho, Hitachi, no.
No,
Like,
exactly.
even the free version, no. And, seeing that you've got just to start telling people, forget the word Pentaho. It's Apache Hop. It's
Yeah.
fantastic software. It'll run circles around what you can do. We don't need to handwrite every connector. We don't need to, we need to get to work and get the Airflow DAGs done is, I think, the primary task of what I've been seeing over and over again. And
Yeah.
so I want to get that ball rolling. Yeah.
So yeah, and so that's why I want to have this 1.0 out, and then we say, okay, so everything, and for us, what is most importantly, certainly, this is with 20 years of experience in the bag, is that our pipelines and workflows, the stuff that we run, is backward compatible and stable. So that's
Yep.
why we never had integration testing in Pentaho, just to. And so that's why this is a top priority for us. So all the critical transforms, the pipelines, the way that parameters are local, passed down, all these kinds of things, they are now tested every night. And if something breaks, we know, right? So it's really not that hard to do now to add more integration tests. I think you added like a whole bunch of them. And with Docker, we just say, okay, what do we need? Well, we have a Cassandra Docker instance, a Mongo instance, a Postgres. We just fire them up as dependencies, test against them, shut them all down again. Here's the test result. Yeah, that's the modern age, right? We're eating our own dog food. So we build our own Docker image, and then we run the test with those things, and we see, hey, this is running. And it's public, so it's all open source. You can see how it's done. What we probably would need to write up is how you can do this for your own project. But
that's
it's getting. We've taken major steps. Let's say. So when we say 1.0, it means like we want to give you the guarantee that we won't just casually break something in 1.1 or in 1.05 or whatever, right? Because that's the sort of stuff that used to happen with Kettle, unfortunately. Yeah.
Oh yeah.
Going from 6 to 7 to 8 to 9, stuff was breaking left and right. And I can understand something breaking. Everybody makes a mistake, and then we just add another integration test and say no, it's not going to break again. Same with unit tests or. What we see is that a lot of the Mockito, we have a really a huge amount of Mockito integration tests between double quotes, right? Java unit test, but they were just not testing the sort of things that people are using out in the field. The distance between the Java code and the actual pipeline or workflow running was too big. You actually need to run like a whole combination of things in a pipeline in a certain setting to test it. And unless you do that, it's
like you mentioned parameters. It's like you need to have 2 nested workflows inside a bunch of jobs, and then you need to have the variable name the same thing, but it's not in the third level of nesting. So how does that pass in this checkbox? Yeah, totally.
Yeah, exactly.
Yeah.
So so that was one of the things I felt was really, really necessary for 1.0. I'm really happy that we have it. Yeah, you can always add more, and we will add more, but we feel like, okay, we're arriving at a space where okay, so this is something we can defend as keeping compatible for the future going forward. Yeah. So once we give out that message with the 0.99, we want to say, hey folks, if you're interested in porting your Kettle projects to Hop, or if you want to start thinking seriously, like you, Jeff, maybe now is the time to do it, so that if there are any critical requirements, we can still maybe take them into account, or we can check them off as saying we haven't forgotten something really stupid for 1.0, right?
Yeah. Yeah. I want to tie it to the Airflow story, and get because now basically I've had so many different jobs, but I'm a sales engineer now, so I want to. It's sort of tangential to selling Astronomer and Airflow, but that there is an easier, better way to do the actual pipelining. So many use cases that just burned me up in the consulting world. We burned a lot of money. We made a lot of money by doing a lot of Python code, but most of that Python code was really unsupportable.
We had the same kind of thing happening at Neo4j, where if business grows at some point, it's also a question of scalability, right? How many services people, great services people, top end, that can write that Python code? How many can you find?
Yeah.
So what if your company doubles in size? If your revenue doubles or triples or quadruples, what then?
Mm-hmm.
How many people do you need then?
Yeah.
So I think you will always have a need for the Python code, but also for these enterprise solutions where things are easy, manageable, visual, whatever.
Right.
Right. There's in my experience plenty of room for all these people as your company grows.
Definitely.
So Jeffrey, if we can talk to somebody in the company or whatever, let us know. We're happy to do another session or in private or whatever. It's
We'll do. I'll ping you on Mattermost. Yeah.
Everybody's welcome in the community, like I said 100 times, and it's true.
Totally. I think I'll reach out. I think we should co-author some articles. Just how to use it, vanilla, nothing fancy. Just here's how you can take a pipeline in the vanilla Docker container, save some code, run it over Airflow. Here's boom, get your job done in a day, kind of thing. So
we already have a couple of approaches that we will document, but there's still work to do.
Totally. Yeah. Like Dieter did an article like 2 or 3 years ago on Airflow plus PDI, and we just need to continue that.
Yeah.
Look at all the things it can do. Because in my opinion, having done a lot of the fancier stuff, most of the time you're already running Airflow on a Kubernetes cluster, so you may as well just run the Pentaho job, or the Hop job there.
Yeah.
And because you're already paying for it. It's usually underutilized. So that's 80% of the stuff is reading off of databases and writing them to Snowflake or BigQuery.
I think that there is a market in that cloud business where you say like, okay, so all my data is in Mongo or in Snowflake, and I want to continuously update my Neo4j Aura instance, right? Okay. Then you have something that needs to orchestrate, like you said. Okay, if files coming in, you can do it with Google, maybe with Airflow, maybe. So So I think there's the building blocks that we're building. I think are super cool.
I agree. Yeah, I agree. Cool. I think I gotta run. Hey, thank you.
Thank you all for joining.
Much appreciated.
It's been a fantastic 2 hours. I hope it was